So this is not the pit post-mortem that you were expecting, but please don't run away. It's gonna be entertaining, that's what I've been promising people. So yeah, this talk is about an educational game that teaches programming to children. So, kind of intriguing, I hope this is why you're here. Let me start at the start. Again, I am Henrike Lode, and it's a very nice picture of me. I was born in 1985 in East Germany, and if you're wondering why the East part is relevant, that'll come in a minute. This is me when I was about 5 years old. I wanted to become a chef or a knight. Turns out I had to be a knight first. I was at war with my teachers for 12 years. I had a very strong opinion on everything, and that's not a very popular thing in East Germany. And I hated the educational system with a passion. And then finally, 12 years later, I could go and do my own thing, and I applied as a joke at the university in Berlin, University for Applied Sciences, for Technology and Economy, and I learned programming. And that's not really a choice that I took for myself. It just kind of happened. It was the only people that would take me. And it turns out I like programming, and I was kind of getting good at it. I was getting so good at it that I was teaching it to other people. And I had the chance to observe a lot of different teaching styles, and I started to form an idea. How can we teach programming in a better way? But then my plans got a little bit derailed. I started working as a motion capture studio manager at the Research Center for Computer Games and Interaction Game Lab for 2.5 years. Helped create a curriculum for a new bachelor, that's interaction design, game design. And in my research, I found the ITU Copenhagen, and that's where I went 3 years ago to study game design. And it was not really a plan like that, but then I realized that my evil master plan of making learning fun was actually gonna come true with making games. First, I had to do a little bit of research. So if you're interested in making learning games, this might not be interesting to everyone, but then you should look at the following 3 books. James Paul G is a genius and has very nice books that are easy to read, so look at everything he's been writing. This is a nice book, Learning Science Through Computer Games and Simulation. It's about informal learning settings outside of school and problematics measuring learning content. And this guy, some of you might know him, Simon Egenfeldt Nielsen, who's the CEO of Serious Games Interactive. And he came up with a pretty cool concept. I'm not gonna go too much into depth, I don't wanna bore you guys. So there's been so much research and so many people have been trying to make good educational games, and somehow everyone still hates them. Teachers hate them, kids hate them, parents hate them, everybody thinks it's the most boring thing you could ever do. When I ask people to work with me on educational games, they're like, can we make something fun? And yeah, the problem is that, let's see, I mean, like, you can already see from the graphics, there's a little bit of a difference. Can you spot which is the edutainment title and which is a real game? And it's not following my link. Come on. My computer's not talking to me. There you go. Okay, so just so you also get a feeling of the soundscape. I don't know actually how old it is.
Look at the pattern on top. Which picture from the bottom completes the pattern?
Can you hear it?
Look at the picture. What is the missing letter? Which one is a reptile? What is the shape of the Earth? Good job. You won the bronze medal.
High five! Yippee!
The best part? Confetti.
Yippee!
And let's look in comparison at a real game. And you notice something with the sound? Soft ending. Oh yeah, no buffer. So I think I made my point. This is why the educational games still suck. And I have another example. When I was playtesting an early prototype, I went to schools and we told children, so we're making this great educational game, we're trying to make learning fun. And let's hope this one works.
You don't think learning and games go well together?
No.
Oh no, that really, yeah. I don't.
It's either games, or there's learning. It's like games and learning do not fit
We're trying
together.
to change that. We're trying to make learning fun.
Learning will never be fun. Learning will never be fun.
So yeah, we're dealing with a big bias here. Like children have been educated in school for years that learning is not going to be fun. That they have to sit down, no running around, 45-minute phrases, sections of knowledge being pressed into people in the same way. So school is a place where fun is going to die. So that's a pretty big challenge, and I lived through it. I hated it, and I want to change that for other people. So there's a few techniques that we found out during our master thesis at ITU Game Design that I was doing together with Niels Frederiksen, who can't be here because he's attending another talk, and Giuseppe Franchi, who can't be here because he lives in Italy. And we found out that there's a great thing that you can use that's called experiential learning, which means no gamification, no edutainment. We transform the gaming content, the learning content, into a game mechanic. So this is a cognitivist, constructivist approach. It means that players actively engage with the learning content and create their own knowledge. So the game goals have to be the learning goals. What you do to play is what you do to learn. It's the same thing. It's not just the learning activity with a funny cartoon character or some cookies and stars slapped on top of it. You want to create intrinsic motivation. You want people to feel confident. You want people to feel smart, to want to learn, and not just give them some kind of a candy bar. And to fool the kid who thinks that learning will never be fun, let's just not tell them that they're learning something. They don't need to. And this means that educational games need to be indistinguishable from other commercial titles in graphics quality and soundscape. And let me tell you that I don't want to make educational games to replace teachers. We still need them. We need them to be debriefed after a gaming experience, to talk about what they learned, and to teach each other, hopefully. So how many people in this room know Csikszentmihalyi and the flow theory? Quite a few, cool. Okay, because I come from a game design background, and I talk to game design students all the time, and I never have to explain this. So it's kind of pretty straightforward. You create a flow experience if you increase the challenge kind of at the same speed as the skill of the player increases. So it's always fun and always more challenging, and you always, like, in between, you don't want your players to be bored, you don't want them to be too anxious that they can't solve this problem. So this is really important to incorporate into any kind of game, but specifically into educational games. And very important, don't make players feel stupid. They hate that. That's exactly what they hate in school, that they have to get everything right on the first try, otherwise some people is gonna think they're stupid. Instead, give feedback, performance feedback. How are you doing? Performative feedback, how could you do better? And especially teach children that failure is an opportunity to learn, to understand why something doesn't work this way. It's not a bad thing. So why did I want to teach people programming? Like all these great ideas, I could teach anything. I want to teach one of the most boring things. How many people are programmers in the room? Ooh! So I don't really have to explain this to you. And I don't really have to explain this to you either. Like, I don't want to create an army of programmers. I mean, I think we could definitely use a few more. There's a lot of jobs out there that go unfilled because we don't produce enough programmers. But technology is all around us. You know that every job, the daily lives depends on it. And even if we don't want to become programmers, we need to talk to them. We need to understand how they work. I mean, like, okay, talking from a perspective of a child. So if you want to read a little bit more about this, is also two guys that you should. I mean, like you probably all know Ian Bogus and Michael Mateas. They wrote about procedural literacy, and this means. I have a quote here: the ability to read and write processes, to engage procedural representations and aesthetics, to understand the interplay between the culturally embedded practices of human meaning making and technically mediated processes. So we're not going to be all opera singers and public speakers and comedians, but we need to be able to speak and listen, right? We're not all going to be authors and poets, but we need to be able to read and write. And we're not all going to be programmers and computer scientists, but we should be able to read and write processes in the future. And don't just take my word for it, listen to Steve. So in my personal opinion, learning programming helps you to understand basically how your brain works, how your cognitive processes work. If you have a problem, you develop a strategy, a series of commands, you execute them, and observe what happens. And most of the time, it doesn't really do what you thought you told it to do, because it's actually a trick in your brain. It's not a teacher there saying, oh, you're stupid, or your peers laughing at you. It's a machine, and the machine can only do what you tell it to do, so it must be in your thought process. And it doesn't mean you're stupid. I found out that programmers are all kind of puzzle gamers, or at least every sort of problem they see, they try to solve as a puzzle, and they see it as a challenge. And the longer you take, the more challenging it was, the smarter you are. It's not like when you fail, you're stupid. So, from theory to practice, how did we use all this information to actually make a good educational game? Well, on my side, I'm the artist, so for me it was really important to make it look as nice as possible. So we used Machinarium as an inspiration. Also because I think that lots of those children's games have those super cartoony graphics, and children don't want to play something that we think is the right age for children. They want to play something that looks like it's for older people, because they want to grow, they want to become those kind of people who play the adult kind of games, or something that looks a little bit more advanced than some weird cartoon characters, at least in my experience. So we have a nice setting and narrative. You're playing as Zola, a young girl who wants to become a machineer, which is a mix of machine and engineers. And you're in the middle of this beautiful amusement park center, and you make friends with the town folks, you help them fix their machines, earn yourself a good reputation, and you prepare for the challenge to create your own mechanical inventions and become the best machineer in town. And your colleagues are some kind of quirky characters with like Geary with a valve on his belly. And yeah, they have a lot of really nice dialogues which just wrap everything up in a nice story. We're using metaphors to explain programming concepts. We don't want to use any code, any math, because this is not really what programming in its core is about. It's just a tool on the way, and that's exactly what makes it so hard to teach, because you always start coding something, and it's really hard to get behind those weird words, that they have a meaning, that they do something. So we're gonna replace control structures with mechanical objects, and that way we transform the programming concepts into game elements. And if that still doesn't make sense to you in those words, I prepared this slide. We have code snippets. Since you're all programmers, you can understand the concept of those. And we replaced them with kind of everyday objects, like this is a knob and a button. It's a little schematic. And this is a meter where you can read the value left or right, and depending on which one is active, it's going to activate the left part or the right part. So this way we build a switch. And we have another level of metaphors. Software is represented by machines, and they look something like this. This is the owl, and yeah, it might be a little hard to see, but this is the brain of the owl, and the right wing and the left wing, as you can see. And when the machine works correctly, the owl is actually gonna move its wings. And so we're giving the player something broken. The red parts is what we take away, and they have to recreate it. They have to figure out what kind of a logical concept we were thinking out for them, and connect gears with belts. And then we give them this nice visual audio feedback, like DJ machine is playing a tune, or There's those glowing letters on a neon sign, and they blink at the same time, and that's very rewarding feedback. And the next level of metaphor is programmers are machineers. This is a profession. This is something you're proud, because everyone in town is going to love you for being able to fix their machines. And you're going to have a nice, confident feeling about yourself. The next level is the learning process, is a journey. We're actually traveling from the amusement park to River City. You're going to build your own vehicle and drive yourself there. Then you're in River City. The next level is Hilltop Village, where you build a flying vehicle. I'm going to get to a little bit more into depth about that later. And we have a really nice help system for different people. It turns out that most puzzle gamers actually don't want any help. They just want to figure it out themselves. But some of those kids, because we don't make a game for puzzle gamers, we make a game for children, for all of them. Some of them never play computer games. This is true. So some of them don't like to fail in this kind of game, need a lot of help. And we have a system where just some character pops up and says, hey, you need some help, how about you try this? And you can choose not to look at those hints. And in the end, we give them blueprints to show how the machine works. They still have to fix them themselves. It's not just a button they click and like, whoa, can't handle this. They just gonna have to repeat what they see on the picture. And this is also similar to the way programming works, that you sometimes just look up the answer, you don't really understand it, you execute it, and it's gonna, through repetition, sink in sometime later. So unfortunately, this is not a formula for creating good educational games. I wish it was. But we took quite a few iterations to go through this process, and you have to do it from scratch for any kind of educational game that you want to make. So there's not a gigantic business opportunity in using our master thesis for making great educational games. Which is good, because then I can make them. So we tested with 21 kids at Copenhagen International School. They were around 9 to 14 years old. Average playthrough time was 65 minutes. And after that, over half of the kids said they want to keep playing after 60 minutes. Have you seen 9 to 14-year-olds that focused with those kind of expressions? When they finish, this is by the way the hardest puzzle, the last one, the crane machine. Few of you guys have probably played this already. It takes up to 20 minutes to beat this machine, and we had like almost everyone having this pose when they finished it. So our players are really engaged in the experience. And then we used the metric system to measure how long they took to solve each puzzle, like how many hints they were looking at. We had a questionnaire and some pseudocode test that didn't really work out so well, because we're not really good at methodology, we're good at making games. So let me show you what all this fuss is about. Show me the trailer. That's not good. HD. Thank you. Let's go back to the slide. And the next one. So, Next step on the way was graduation. We all got top grades for our master thesis in the fall 2012. Giuseppe by now has moved to Italy, and then we did some showcasing at the Future and Reality of Games and at the Viborg Animation Festival. That was really nice. They actually built a whole cardboard box forest, and they made us this little robot where they put 2 screens in so people could play. It's very cute. And then we got some funding from the Danish Film Institute. That was very nice and a hard job because it was 3 days after the handing of my master thesis. So yes, that was pretty tough, but I had lots of friends helping me. And then the amazing thing happened that we applied to showcase the game at the Serious Games Showcase and Challenge. That's part of ITSEC. That's the world's largest conference in modeling, simulation, and training industry conference. And I met a lot of great people there, and had even kids testing the game, showcasing for like 4 days. That was an amazing time in Florida. And then we won the Best Student Game Award. And I don't know if there's lots of Unity people here, but you might recognize Davy Jackson over there. And in his hand, he has 2 full Unity licenses that we won with this award. That was very sweet. And we even won another award just like 2 weeks ago, I think, at the conference on human factors in computing science in Paris. That's the academic world. We had to pay a lot of money to get there, and they didn't have free food. So academic world conferences, but at least we got a reward. Don't want to bitch too much. And in the meantime, to get the money from the Danish Film Institute and to actually keep working on this kind of a prototype that we had made, we had to form a company. And we call ourselves Logica. That's logic in Filipino. And we were able to hire a few more people, like Yannick, our programmer, who is right now writing his bachelor thesis. He should be here. He should be giving part of the talk. But he's too busy to be there tonight. Niels is, like I said, at the other talk. That's this guy. And we've got Michael Fischersen from Omnisound Copenhagen doing the sounds for us, and Morten Lennart Sørensen from Dapper Games from Viborg to make the animations for us, because I used to do the animations. I have no education in doing animations whatsoever, and I need to focus on business now. And on the far end is Giuseppe, our Italian member, who's now a sole puzzle and game designer, working from Italy. And in the last couple of months, I had to learn a lot of new things. I thought I was just going to make games, but apparently we also have to have shareholders agreement, have to figure out what to do with the IP, write contracts, bookkeeping system, payment system for the salary, and manage production that's about 6 times larger than I've ever managed. So good time to panic and freak out. But we were lucky. We have a lot of friends in the Copenhagen and Nordic region indie scene who help us out all the time. Thank you, guys. I would not be here if you hadn't helped me. Daddy Greenhouse is helping us. I don't know if any of you know what that is, probably not. It's a mentorship incubator, so we meet every couple of weeks and they help us with PR, with lawyer stuff. And there's another thing, Growing Games, where I learned pitching. I learned to pitch the game in 30 seconds. Please don't ask me to do it. And here comes the Unity slide. So this was supposed to be done by my programmer. I just had a Skype call with him 20 minutes ago, and he told me what to say. I might not be able to reproduce it exactly the way he would like to. But so we used the asset store a lot. We used Easy GUI, and we were using a road tool for a feature that I can't show you yet because it's secret. It's not really that secret, but it's not really done yet. But it will be done in a few months. And obviously we're using the asset server to commit our changes. And that's been really great since we've been working from different countries. And we don't really have an office yet. We're working out of the university most of the time. And we're doing this thing because we're porting for the iPad. We're doing our now 3D animation. I used to do 2D animation and sprites, and they're taking up lots of space, and you can't really do many animations. So now we're doing those in 3D on 2D planes. I think you probably know what that kind of looks like. And I don't know if anyone has done this, but everyone who has knows this problem with the Z-sorting of the meshes, that they're back to front. Why are they back to front? It doesn't make sense. Please change it. And he asked me to tell you that he loves that he can just plug in his phone and test that and it's going to behave the same way the iPad is, while building it for the iPad, thanks to the whole Xcode thing with Apple, takes a lot longer. And yeah, that makes testing the game and tweaking some features really easy. And also, in case you were wondering, I'm not really sure what it means, but link doesn't work on arrays. So don't try to use it if you're working with the iPad, because apparently you need arrays for ray tracing and some touch things. And yeah, so you had to rewrite some code that he was writing. Link makes things easier, and so he's sad he can't use it. I don't know if I can ask Unity people to implement that. I don't know. And yes, editor scripts. So we can launch our external dialogue system. We're actually translating the game to at least 5 different languages now. It's Danish, English, German, Spanish, Italian, and we want to translate it to a couple more Nordic languages. And we have a nicely built system that I think he made it in Java, and we can just launch that through the editor scripts, which is very nice. So much to Unity. Thank you, Unity, for helping us making this great game. So we're gonna release chapter 1 and chapter 2 of 5 chapters on the App Store at the end of this year, fall, something like that. And this is some couple of mood boards about what we're gonna do next. So we're actually almost starting to work on River City. We have designed lots of cool new puzzles, like a fountain and an instrument called a hydrolophone. Everything is working somehow with water. It's really nice. So this is just mood board images from the internet. You can probably recognize a lot of game or film things there, and it's just an idea of how the future levels will look like. So River City, you're gonna build your own boat, drive yourself up the stream to Hilltop Village. In Hilltop Village, you will build yourself a flying vehicle, and I really, really want to build this hot air balloon. It looks amazing. And then you're gonna fly to Skyrim Island. I think I have to change that name. I think I'm gonna get into trouble for using Skyrim. It's an island at the rim of the sky. There's other things there. So then everything's gonna look a little bit like bird nest kind of stylish, and you're gonna build a spaceship and go to planet, I call it Y now, it's I think probably something HX2 0.512 or something. And there you're meeting the professor who is working on some very mysterious machine. Spoiler alert, it's a time machine. Awesome. And another thing we're going to do is we want to get this game into schools, which is the biggest challenge right now. So I have this idea. This is a mock-up for a website that the teachers can use to compare the results and monitor the progress. They can actually look what they're building right now, and then they can look at, for example, the vehicle that the kids built and how it works and how much time they used on the hints and on the different puzzles. And my favorite idea of this whole thing is they can use this thing to feed performative feedback back into the game. So the kids are actually never taken out of the game into some kind of a questionnaire or some kind of a non-game setting, but the teacher can deal with them through this portal. I think that's gonna be cool. But we're running out of money. The DFI money is awesome, and it's gonna let us survive until the end of August, but then we're broke again, and we can't really see if we're gonna make a lot of money by just putting it on the App Store. I doubt it. So we're gonna need some investors. And oh yeah, if you guys are going to Nordic Game tomorrow, I'm gonna be at the live pitch event. I think it's at 4. It might be right here, I think. So if you don't have anything else to do, please come by and support me. They have a complicated voting system where a third is through some website, a third of the votes is from the people in the audience, and the last third comes from a panel of judges, investors. And one of them is known for making people cry. So you might have to hug me later. And yeah, of course, we want to use this money to integrate this into the schools, do some more research, prove our success in a real scientific way. and of course develop the next episodes. So this was so much of my talk. Thanks for listening. We can do a Q&A session. I think we have a lot of time, probably. I don't know. I didn't measure the time. And I have the game with me on my iPad, so just talk to me later if you want to play it. If you want to contact me. Also, if you don't have the time to play the game today, go to the website. The demo is there for free, 3 puzzles. I have all 7 with me. Okay, so thank you. And hit me with your questions if you have any. I see one over there. He's on this way with a microphone.
I was just wondering if you had looked into tangential learning as well as the stealth learning, and trying to nudge them in that way as well.
I'm not sure I understand the question.
Tangential learning.
Yes.
Have you looked into it for adding learning potential to the game?
Not so much at this point, but I think it's not really very far off. I think they are pretty complying, the approaches.
Thank you.
Sure. Anyone else? Anyone wants to make educational games? Woohoo! Cool. Well, in any case, if there's no more questions than that, is there anyone raising their hand? I have a hard time seeing with this thing in my head. Anyways, talk to me later. Find me later. Buy me a beer. Thanks.